Dr. Boyer, we're back for part B of prehistoric
Mr.
astronomy.
Bergmann, we are. Let's do this.
Prehistoric astronomy. So more about what the ancients do. So this is what you can see, like, well, with your naked eye.
Aha! Stonehenge.
Hey, you talked about that last time.
Yes, indeed.
Now, where is Stonehenge?
It is in England.
England, okay.
West of London.
West of London. Okay.
And it is an ancient astronomical observatory. That's what it is. They measure the summer and the winter solstice.
So like the sun come in a certain time, they come like through this hole or something
Absolutely.
like that? It's shown in a certain place.
It's incredibly accurate. It was amazing.
Very cool. Yeah, all right.
And there's other things it does we still don't understand.
Very cool. All right. All right. So, yeah. All right. Now we're talking about something that's a little bit confusing. Okay, it's called the celestial sphere. Now you got to realize they don't understand, the ancients didn't understand that the world rotates. They thought that the sky rotated. So we've actually kept the same system of measuring the Earth called the celestial sphere. So let's just sort of make an assumption. We have a celestial sphere right here. So if I take the celestial sphere, you notice that the Earth is here in the center of the plastic globe. And on the globe are the stars, right?
Yes.
And so if you take a look at the pictures now, we can essentially, here's the Earth, and then out here you'll have a star and a star and a star, and we assume all the stars are equally distanced from the Earth.
That's right, because that's what it looks like.
Because that's what it looks like. The brighter ones are just bright stars.
Just bright stars.
And then the dimmer ones are dimmer stars,
That's
etc.
right.
And so you make a big dome around the Earth, as you can see is done, and we've got that modeled over here. There's some problems with that, of course, which created problems. Here's this in the big screen, so we can see that. Okay, I think we can see that. And then here maybe is a better picture. Here's the Earth, and you can see a star here and a star here. And all these stars that are located all over the celestial sphere. And so that gives us kind of a way to coordinate, or to have coordinates, I should say.
Coordinates, exactly.
Coordinates for them. You know that on the Earth there's latitude and longitude. Well, in the sky, you kind of have like a latitude and a longitude. They don't call it that, but it's something like that, isn't it? Okay? So, actually, let's go back here and say one more thing about this. In this celestial sphere, what you'll find is that we're going to be playing with these guys, these celestial spheres, a little bit later, and we're going to learn a ton of things about how it all works. Okay? So that's coming up. All right. When you're looking at this night sky, you can see something called a constellation. What the heck's a constellation?
Constellation is just a pattern, and that's it.
Yeah. So
and what the pattern looks like is your choice.
Yeah. Some people like to think there's animals.
Yep.
You've heard of Leo, Cygnus, etc. Leo, and then there's some that look like people, like a guy named Orion, Andromeda.
Princess.
And some look like objects, like the dippers.
Yep.
The big
Exactly.
and the little dippers. So you can do that, and so you can see a picture of them right here, and this is, of course, is Leo.
Yes, indeed, the lion.
Dr. Boyer, I never saw how this looks like a lion. I guess.
What do you mean? Can't you see the lion? I mean, it's got 4 legs, a
Four
tail,
legs.
a head. Yes.
I don't know. Looks like a horse to me. I'd call it Leo the horse. Well, whatever, you know. Anyways, but it's a constellation. It's just a grouping of stars that they can draw a pattern on.
Yep.
So that's what a constellation is. So Leo is one example of one of those. And here's
now
Orion.
Here's a much better picture.
Orion's a pretty cool one.
Yeah.
So, you know, Orion, you can see, Orion's a Greek, Roman god, something like that. Greek god.
He is the warrior, the hunter.
It's usually easy to see this right here. These 3 stars, they're called the Belt of Orion, and they are relatively easy to find. They're very, very bright. One of them up here is Betelgeuse, the star Betelgeuse, which is isn't it one of the biggest ones?
It's a red giant.
A red giant. We'll talk about him. Rigel is another huge star.
A blue giant.
A blue
yes.
giant. Very, very bright stars.
What's neat is that this constellation is easy to see right now. As soon as the sun goes down, wait an hour to get it nice and dark outside, look up in the southern sky, you're going to see 3 stars right next to each other. Boom, you found Orion.
Right now is January the 18th. So this is sort of a winter constellation.
This is the central winter constellation.
Yeah, okay. So where we live, at least here in the northern hemisphere.
Yep.
Now, something that you may not quite get is that the stars appear to move. So if you go out at night and you look at the stars, they appear to move. Now let me illustrate that by going to Google Sky. Now, interesting thing is that the stars appear to move through the course of a night and actually through the course of a year. Let's take a look at this in my cool program that shows us the stars. So here I am looking south
southeast, I guess, from somewhere near Pueblo, Colorado, in the United States. And we can see the stars. Today is August the 10th, and let's say it's 8:30 p.m., and we see some different stars. Okay, I think I hover over a star, I can find out the name of a particular star. That's Tar Azed. It's the name of the star. But now I'm going to push this, and we're going to play it at 3,000 times the regular speed. And I want you to notice the star. So take a look at this star right here. Actually, that star is Jupiter. It's not a star. But let's take this star right here, Markab. Markab, if I then play, watch as Markab moves, you see, and there's the moon, in fact, moving. And so as time passes, the stars appear to move. Now we're coming into the day. In fact, there's the sun right there. So the sun is moving through the sky. But the stars, over the course of a night, they move. Let me move them really quickly, 30,000 times. All right, let's go back to 3,000. So now they're moving. The stars appear to move over the course of a night and the course of a day. The sun, of course, moves as well. So this is in real time, all the different stars that we have that we can look at. And the shadows, as you can see, are changing here by my trees. And it's about to get dark. One more day here. And the stars appear to move. Now, if I look at this, they actually appear to move around what this red circle right here, which is essentially the North Pole. So I'm kind of looking straight up. And
so you can see how those stars appear to move, Dr. Boyer.
Exactly. In fact, this picture right here,
it's a classic picture, yeah.
It's classic. The camera's pointed right at the North Star.
That's the North Star right there.
That's it. They left the camera lens wide open, and it recorded the movement of the stars.
So the stars move, is this the right direction? I think it is. They move clockwise. Yeah, that's right. They go from east to west. West to east. Is that right? Am I doing it right or backwards?
The other way.
The other way. Okay. So anyways, the stars appear to move in this direction. Ignore that. So they appear to move this direction. So this star started here, and he became over here over the course of an evening, doesn't it?
Yep.
And so, but here at the North Star, it doesn't appear to move. So,
no, it doesn't.
You know, and so if you look at the celestial sphere, which I just almost broke, what you can see is that they rotate in a particular direction as they go around. Now that's what they appear to do. Of course, what's actually happening is that the stars are in fixed locations and the Earth is moving. So that's what's going on. So, so in the north, the Earth rotates with respect to Polaris, the North Star. Right?
That's right.
Okay. So the ancients believed that the sky rotated around the Earth.
That's right.
You know, based upon this whole thing, right? When we talk about this rotation thing going on, that's what they believed happened. Of course, it's not correct.
Not correct, but that's what they saw. So how could they believe anything else?
It's a reasonable thing to believe, isn't it?
Yeah.
Okay. So now let's talk about the path of the sun on the celestial sphere.
Yes.
So how does the sun doesn't move in the same pattern, though, as the stars.
No, it does not.
So that was kind of a weird deal. What happened there? Can you draw that picture-ish on there, Dr. Boyer? I bet you could.
Yeah.
It does something kind of odd.
Kind of odd. If you looked at the path that the sun takes, it kind of makes a tilted orbit with respect to the Earth. And, of course, according to our nice little sphere right here, the little yellow dot here represents the sun, and you can see as it moves around the Earth that it doesn't move around what we would call the equator of the celestial sphere. It moves up and down with respect to the Earth. And we call that the ecliptic.
In fact, that's called the ecliptic here. That brings us up to our next slide. The ecliptic in the celestial equator, because of the tilt of the Earth. We now know why this is. The ancients didn't know this, but there's the tilt to the Earth. And so the Earth, you know, has a tilt. So if you draw an Earth, it has a tilt, 23.5 degrees. And that is what causes the ecliptic, or the sort of odd pattern of the sun.
Exactly.
So so the ecliptic is, what is the ecliptic?
The ecliptic is
By definition.
actually the plane, the surface upon which the sun and all the planets move on.
Oh, wait a second. You didn't just say the sun. The sun plus
and the planets.
the planet. So it's not the ecliptic. The planets follow the ecliptic and the sun follow the ecliptic. Because
exactly.
We've been talking about stars, but there's planets out there and they do weird things.
Yep.
They follow the sun, so we can do that, but they do something else that really stymied and confused the ancients, called retrograde motion, which we'll talk about, I think, in the next podcast. So here's a pretty good picture of the ecliptic, which you drew, and you can see the ecliptic is this sort of, I think it's the blue line, right?
Now, blue line's a celestial equator. The red line is
it's the red line. Okay,
ecliptic.
So I'll draw it in red here, probably.
Yeah, there we go.
There's the ecliptic
Hey,
right there.
yeah.
And then this is the equator. Now, not the equator of the Earth, but the celestial equator,
Yep.
which goes through our equator, though,
It
right?
does.
Yeah. Okay. And then lastly, and this is a pretty good image that kind of gives you a perspective, is that where does the sun, well, why don't you explain this, Dr. Boyer? You're going to be better at this than I am.
Well, remember we talked about the ancient astronomers noticing that at different days of the year that the sun was rising at different positions, and the other thing they noticed was that the sun was actually getting higher in the sky, so that in June they noticed that in the northern hemisphere the sun was as high overhead as they would ever see it, and in December the sun was as low towards the horizon as they would ever see it. The sun appeared to be moving up and down the sky. And that's because the sun follows the ecliptic, which gives the sun apparent motion up and down with respect to the horizon.
It goes up and down.
Exactly.
Okay, so yeah, so right now here in early January of 2010 when we're recording this, it's, there's January. December, January is going to be maybe right in here. So we're kind of right in there,
Exactly.
where it's going to be just almost at the lowest portion. It could be here in the northern hemisphere. Southern hemisphere, of course, this is all flipped, isn't it?
Yeah, it's
And
their
they have
highest in the
just
sky for
highest
them.
ones.
They have
They're
summer.
doing barbecues in Australia right now.
Absolutely.
Yeah, not dealing with ice storms. and
I'm
such.
getting hungry.
Okay, well, folks, that concludes this podcast. We will see you in class. Goodbye.
Bye.